So our next problem is kth largest element in a string. Okay, we have solved the problem kth largest or kth smallest in an array. So what is the difference between array and stream? Whenever you see stream is a continuous flow of elements. Okay, so what is given? We have given a kth largest function. Okay, here kth largest function is given, and we have given an add function. We have given an add function. Okay, and what's happening that we have given a nums vector. Okay, so in the nums vector we have given some numbers. Let's say here we have 4 5 8 2. Okay, and we have given k, so k here is 3. So if we want to find the kth largest, so I want to find the third largest here. So third largest will be this one, 4. Okay, eighth will be the largest one, fifth will be the second largest, fourth will be the third largest. But here add function is also there. Okay, so if I add some value, let's say I add 3 here, so I add 3 here in the array. Now what will be my kth largest? Okay, so we'll keep on adding. Whenever we'll keep on adding, the kth largest will be changed accordingly. Okay, so this is nothing but a stream. In the previous problem of kth largest element we had array. Okay, so we had given a particular array, but here the arrays keep on changing. Okay, we are keep adding the elements in the array, so this is stream. So it is similar to the previous problem, only what we need to do, we need to take care of this, how we can put our logic in these functions. Okay, so you can say that these are a kind of design problems. Okay, whenever you will see some design problems, you will given something like this only. Okay, now you need to design how you can put your logic in this function. Okay, so let's discuss how we can solve this. So we have given this kth largest function. Okay, this is nothing but a constructor. So a class is created of kth largest name, and this is a constructor inside the kth largest class. Okay, so what is happening outside? So we have given something like kth largest. Okay, this is the object. So we are creating the object with some values. Okay, so in this we'll pass something like k. So k will be 3 here. Okay, and we will pass a nums array. So let's say we pass 1 2 3 4. Okay, so this is a constructor of class kth largest, and we are passing some values to it. Okay, so k will be 3 and nums will be here. Okay, so we are assuming that in input we have given this k and nums. Okay, so whenever we are calling this constructor, we'll have the k and the nums. Now whenever add will be there, okay, so there will be some value passed to this function add. Okay, so if I want to insert 4, so 4 will be passed to add function. Okay, this is given to us, right? Now what we need to do, we need to use this k, nums and value to to find the kth largest in our stream. Okay, so what will happen, this add function, it is return type is int, so it will return the kth largest, okay, after inserting value well. So let's take an example. So let's say we have 1 2 3 4 5. Okay, this is given in nums, and we have given k equals to 2. Okay, I want to find second largest. So what will happen, we will use this here. Okay, so here k is accessible and here nums is accessible, right? Here this array is accessible. So what we can do, whatever we have done in kth largest in an array, we can use that logic here. Okay, we can use that logic here. What we have done, let's write it quickly. So what we are doing, we were taking a priority queue. Okay, and we were pushing the elements. So in kth largest, what was the optimal approach? Either you can use max heap or min heap, but min heap was better in case of largest element. In case of finding kth smallest, max heap will be better. Okay, so vice versa. For largest, use min heap. For smallest, use max heap. So assume I am using min heap here. Okay, I am using min heap. Min heap. Okay, so what is the syntax of min heap? Let me write it here. Okay, it's a very long syntax. So how to declare min heap? How to use priority queue as min heap? What we can do, we can write it priority queue. Okay, and int comma vector int comma greater int, that you need to remember. Okay, that is syntax only, comma pq. Okay, so I'm writing min heap here only. Okay, I have defined the priority queue here. Okay, now what I can do, I will take the priority queue of size k. Okay, so what I will do, I'll keep inserting the elements. So I'll put all the elements from 0 till nums. Okay, and if I'll keep on pushing the elements, so until if my pq dot size is smaller than k, then I will keep on pushing the element. Okay, I will push the element, so it will be nums of I, let's say, right? And in else part, what I will do, else I will check if my pq dot top, okay, if it is smaller, if it is smaller than my current element, okay, so I will push that element. So if it is smaller than nums of I, then I will pop the top element and push the current element. Okay, so pq dot pop and pq dot push nums of I. Okay, that we can do. It is same, this logic will be same as kth largest in array. Okay, because what we are doing, we are putting the elements from nums to my priority queue. Okay, so here I am taking the min heap, so my priority queue will have, now my priority queue will have, let's say I put 1 2 3 4 5, my priority queue will be of size 2. Okay, so it will have 4 and 5. Okay, this is a min heap, I'm taking min heap, so it will have 4 and 5. So till now 4 is our second largest element. Okay, that will be on the top. So this logic is for kth largest in a array. Okay, now how we can use that logic in our add function. Okay, so let me take add function outside here. So my add function will be int add, it will take some value. Okay, and how to write the add function, so add function will be also same as our kth largest function. What we will do, we will take this value. Okay, we will take this value and compare this value instead of nums of I. Okay, but we have declared the priority queue inside our kth largest, so priority queue is not accessible to this function. So what I will do, I will declare this priority queue outside my kth largest. Okay, so I will declare it outside this function. So let me declare here only. Okay, I have declared here, let me write the whole code. I have taken the min heap of size k, but k is also not accessible to this function, but k is accessible to this kth largest function. So what I can do, I can take a variable and store the k in that variable. Okay, so if I take, let's say let's say k only. Okay, I am taking the same name. So what I can do here in this function, I can take this dot k equals to k. What does it mean? I hope you understood this logic, right? We are assigning local value of k in global value of k. Okay, so now this k holds the value of my k. Okay, so now k is accessible, right? Because I have taken this outside. You can take another name. Okay, if you take another name, no need to write this dot k. You can simply write, let's say if you write capacity, you can take capacity variable also. Okay, let's take capacity also. Okay, like this. You can take this also. Okay, you can take any name. The logic is we want to access the k outside this function. Okay, now what I will do, I will do the same logic here. Okay, so I will do the same logic here. If my pq dot size is less than k, then I will push pq dot push value. Okay, other than nums of I will push value here. Now in else part, what I will do, I will put if same logic, pq dot top is smaller than value. Okay, then what I will do, I will do pq dot pop and will push pq dot push num value. Okay, and at the end I will return I will return pq dot top. Okay, I will return the top of my priority queue, so that will hold my kth largest element. Kth largest element. Okay, so as more as we keep on adding the data, it will keep on arranging the data according to our min heap property. Okay, so every time it will hold the kth largest value at the top. Okay, so it is same as kth largest element in a array. This logic will be, just this logic will be added. Okay, so let's code this problem. So what I will do, I'll first take priority queue and k outside the those functions. Okay, so that I can use them in add function. Okay, so let's take a priority queue int comma vector int comma greater int. So we are using priority queue as min heap. Okay, you can use priority queue, the default priority queue as min heap also. Okay, so see the logic for that. Okay, what you need to do, you need to add just minus before inserting the elements, but you will get confused in the negative sign. So better remember the syntax and it will get easy for you. Okay, one or two times just write the syntax, you will learn it. Now take one more variable k, or let's take capacity. Okay, in kth largest, what I will do, I'll simply let's take num size. Okay, and I will run this for int I equals to 0, I smaller than nums dot size I plus plus, or you can use for each loop as well. Okay, so what I will do, if my pq size is less than k, I'll keep on inserting the elements. Okay, so pq dot push nums of I. Okay, in else part, what I will do, it means that we already have a pq size as k, so I need to compare the elements with current elements. Okay, so else, if, let me write it here only, if pq dot top element, if top element is less than my current element, then what I will do, I will pop out that element and push current element. Okay, so pop out that element and push current element. So our current element is nums of I. Okay, that's all you need to do in this function. Okay, now you have stored all the elements in priority queue, all the elements of nums in priority queue. Okay, in the form of k elements, you have stored at max k elements, but that k will be k largest elements. Okay, so that's all we need to do with this function. Okay, now come to this function. So what we will do, we will use that same logic. Okay, we will use that same logic here all. Okay, nums of I will be replaced with val, and at the end just return what, return top of the priority queue. Okay, that will contain the kth largest element. Okay, so let's run this. Okay, I have not, sorry, I have not initialized it. Okay, it will be k, and here compare with k also. Okay, compare with capacity, and yeah, let's run this. So it is working fine. Let me submit this. So it is accepted. Now what you can do to avoid the confusion, just name it as k only. Okay, small k, and here you can take this. I hope you know what is this keyword. Okay, now just replace it with k only. Okay, let me submit this. This is also accepted. Okay, so make sure that you use minimum variables as you can. Okay, because more variables, more confusion will be there. What is capacity? So you need only k here. Okay, so just take k here itself. So here you know that what is k. K is the size of heap. Okay, so this is all about this problem. And what will be the time complexity? So it will be, we are inserting all the elements. Okay, keep on inserting. So it will be n log k, because, okay, let me write it here. Time complexity will be order of n log k, where k is the heap size. Okay, we are using min heap, So the time complexity will be same as previous problem. Okay, n log k. Now here add function will take what? It will take log k operation. Okay, every time it will take log k operation. Okay, so if you are doing 10 times add, it will take 10 log k. Okay, and k is whatever, k is here 3. Okay, k is constant, right? So you can say, you can avoid that constant also. So you can say it is order of one operation itself. Okay, if k is small. And space complexity, we are using priority queue, so it will take order of k space. Okay, and other than that, we are not using any extra space. Okay, yeah. So this is all about this problem. Let's move forward to next problem.